Draft physics video. Yay. So anyway, a couple of things. First, Jeff Yi, guy that the dissident science guy David had interviewed last week, has agreed to have a conversation with me, which is kind of good. And so it should be Friday or Saturday. I might do a live room tomorrow or today, Thursday, just to test things. It all, it gets quite swampy, just this technology thing. It should be kind of simple, but I mean, the weird thing is I'd like to do a live room where I can stream this software into the live room, but then the problem is it's just one of those rooms where you can't get people into the room. So that's not much good. But anyway, I mean, we should be able to do the standard YouTube room. And, if Jeff sees this video, you don't really have to install the live video crap from YouTube to get into a room. Getting in is kind of easy, because all it has to do really is recognize your camera or your microphone. You can even go without a camera. You can just go with a mic. But anyway, so that's like just HTML kind of stuff, HTML5. So it doesn't really have to, just loads a little bit of software. I mean, you don't have to be able to do the whole live thing. But anyway, it does get complicated. Logistics. But anyway, so yeah, I'll make sure my technology works and such. So what else I want to, yeah, so that's it. So a link to his channel below. We've so I think it'd be an interesting conversation, just because it's this right-left thing. This, you have two choices, 50%, 50. You go one way or the other. Plus, minus. Benjamin Franklin got that wrong. Gravity's a particle, gravity's a wave, or wave-particle. Even duality is a good one. So anyway, he's like, he deals with wave-particle duality by emphasizing the wave thing. And I obviously deal with it by saying waves are silly, and it's all particles. It's all discrete little bits interacting. It's all bullets, and you can fire bullets at a frequency, but that doesn't mean it's a wave. Anyway, the force bits are under no tension with each other. It's the matter bits that are in tension. That's sort of the difference. Key fundamental difference. But anyway, so it should make for an interesting conversation, because we both see the explanations of conventional physics as being kind of cop-out, simplistic, wooish, reaching, incomplete, sloppy, knee-jerky, retarded, and we just did the 50-50 thing. What part of it's wrong? And we've chosen differently, and so it should be interesting. Anyway, so on to I did do a little interferometer experimenting on my messy porch. It's a nice cement floor, and it's only cement floor I have, and it's cold as fuck. But anyway, and so I just used the thin film thing I had made, and but clearly I want to try it with just a plain piece of glass, because plain piece of glass reflects pretty good too, especially with lasers. There's so much extra energy that you can almost use anything as a splitter that has any transparency at all. So anyway, I did find exactly what I thought, which is the two paths don't have anything to really do with any of this thing. But anyway, I'll get to that. So I'll play a little bit of this video of it, and then I'll explain what's in the video. I think that's the way I'm going to do this. So, where's the video? Here it is. So I'll play this, and hopefully it'll work a little bit. So that's the path. So there's two paths. So that's the long path I decided to make longer, and this is what's getting shot past the laser. So it's going through the beam splitter, off the mirror, back through the beam splitter, all straight line, and it's going back into the laser. And I have it out of alignment, so it's missing the laser and going above it. And so you can see that it's a pretty good pattern. It's you got pretty good rings. And if I move the mirror, the pattern moves just like you would expect the pattern to, and the center gets light, dark, and you get the effect. But you can see those are pretty good rings, and they're not on the focus of the beam, which is a little bit strange, but that's because that beam, the one you're seeing, is actually the reflection off the other path. The ringed one is the one so the two beams aren't lined up. They're close, but they're not in alignment. So the straight path is creating the Newton's ring thing, and when I block the other path, it's still there, and it's likewise for the other side. The straight paths produce the ringed pattern. The bent paths, the 90-degree path, is just a dot. And continuing. But you can see a very good pattern, really. And so that's on the door above the laser. So it overshot the laser and went to the door. Cigarette butts, garbage, laser. So the laser's going through the beam splitter, off the mirror, back through, passed over the laser, and creating the pattern. So this is the other leg of the, so there's a little cam with a mirror on it. Goes back through, and you can see on this piece of paper, not as clear a pattern, but I'll explain what you're seeing. So again, the two beams are out of alignment. So the little beam is actually the reflection off the you're going sideways, and the one that went the straight path, that is, it took the 45-degree, hit the mirror, went back straight through. The one that goes straight, the last leg through the beam splitter, is the one creating the ringed pattern. Now I'll put my hand in the way of the opposite path, and it should knock out the little dot. I think that's what I'm going to do. See, I'm putting my hand in the way of, I don't know what I'm doing there. So yeah, so I'm not taking out anything with that. So I'm not sure what I was blocking something, but it obviously didn't do anything. But you can see that there I'm moving the can. So I'm moving the can with the mirror just to prove that that's the pattern's being caused by the straight path. And you can see it moves just like you expect. The center changes and all that kind of crap. Obviously, in my opinion, nothing like the wavelength of a light. I'm not moving the can much, but I'm obviously moving it a lot more than the wavelength, a lot more than 700 nanometers or 300 and 490 nanometers. 390, whatever it is. Alright, so the other video should be this one. Well, I shouldn't pull it off of there. That's off the camera, so I can't use that copy. I gotta use this copy. Alright, I don't know if this might be a little better graphically, I don't know. So this was the interesting. So when I block the path, the 45-degree, I mean the 90-degree path, the single dot, you can see all these little lines. So it doesn't create the rings, it just creates a lot of little lines, which is interesting. So the hard dot has lines, the absent dot has rings. So I have to figure out what that is. So you can see the two aren't in alignment. When I block the other one, you can see that. See, the two are a little bit off here. So if I can go back a little bit, you can see, so they're not in perfect alignment. But even when I had them in perfect alignment, it didn't change anything. So one beam has circles, one beam has lines. So that's a difference right there. That's kind of weird. Circle, lines. You can see that pretty good. So I think that's all this video was for. I think I want to try it. So then when I block the other path, the circle path, you can see then it just leaves the line one behind. When I block the other one, it's just the lines. Then I'm taking the lines out, the circles are still there. So you see one path has nothing to do with the other path in terms of the pattern. And obviously this other path is doing the same thing, it's just you can't see it as well on the door. You almost see it on the floor though. I probably should have videoed the floor. But anyway. And I think I kicked the laser or something here. And I think that's the end of the demonstration because I screwed it up. Anyway, alright, so I will now attempt to illustrate what I'm talking about, and yeah, hopefully I'll be able to accomplish that task. So I think this is the one that goes down. Yes, oh, I did that correctly. Amazing. Alright, and then if I have time I'll get to some comments, but I don't know if I need to get to comments. I'll just do one comment. One snarky fuck. Excuse my French, but people really are just so abusive for no good reason. I haven't insulted you personally. I'm insulting your religion. You know, grow up. I'm allowed to do that. Your obligation to defend it with something better than personal insults, you lame pieces of crap. Anyway, alright, so paper is here. Yeah, this should work. Alright, so here's the basic thing. The mirrors, and that'll fit. Okay, and so we have the laser beam, let's say shooting here, and then we have the beam splitter here, and what else do I got to add? Oh yes, and the target here was one of the targets. Let's draw a target like this, and then the other target is happened to be behind the laser. Alright, so what I was basically pointing out is that the ringed pattern doesn't show up. Yeah, I ran out of paper. Okay, well anyway, the ring pattern is showing up here. Alright, so I'll just draw it here. And it's from the light going through the beam splitter to this mirror, and then coming back through the beam splitter to this target. And the, let's see if I have, I can do it in blue. And the other ringed pattern here, when it's ringed, is this path. It goes to this mirror, bounces off the mirror, and goes straight through the beam splitter. So it's the straights that I'm really talking about here. It's the ones going that end up the last leg going straight through that end up creating the ringed pattern. And the ringed pattern is happening completely independent of the other path. So if I take this out of the experiment, this pattern still shows up, and if I take this out, this pattern still shows up. So creating the ringed pattern only requires you to go through the beam splitter twice. It doesn't require anything more. Just to hit it twice. In this case it's only reflecting and then going through it once. In this case it goes through it twice. So this is the path usually ignored. And you know, because it obviously usually goes back into the laser, so no one ever sees this path. But this path is still ringed without this path. So this traditional path creates rings even if this path doesn't exist. And the only part that would exist is the part where the light does transmit through and I block it, so it gets this far. So the only thing that really happened was there was light that went through, so it might have affected the mirror in going through, it might have affected the beam splitter going through, and then this path reflects and has to go through the same area that that light is going through. But again, it wasn't exactly lined up, so I don't think the explanation that this could possibly have an effect would be reasonable. So I think it really just depends on, you can just do this, you can create the rings with just one path, and I think that's a clear point made so far in the experiment. Now, when I did have them as lined up as I could line them up, you know, when I got it as close to correct as I could, I didn't notice any change in the pattern. These patterns are pretty strong, and they just don't get weaker or get faded out or change in any substantial way when I finally get both beams to overlap each other, which means this one sort of disappears in the sense that it doesn't have a focus. The ring still exists, so even when I get this beam to go right back into the laser, you know, exactly where the input is, it goes right back the same path. Even when I do that, the rings still exist. So even when it's perfectly aligned, this pattern is still visible because the light's going right past the laser. The ring pattern is obviously created early, and it goes right past the laser. So you just lose the focus, but you still have the rings. So yeah, I'll have to think about what the implications, but this is exactly what I was sort of predicting. We'll see what Hasliday finds in his experiment, but clearly you don't need the two legs with a thin film as a reflector. And so another point to be made is what's happening when it goes through this diffraction gradient is there are other focuses, you know, of the light. So both of these places have other choices. You can make different choices about which little beam of light you choose, and so I chose the maximum, of course. I chose the center ones. So I'm getting the center of the ones getting diffracted by the diffraction gradient. I don't know if that's really relevant, but I just mean there is a bunch of other rays of light flying around in the experiment, but they're not really relevant because they don't go back through the splitter. So anyway, so far no evidence of any interference, just evidence of an interference pattern being caused by photons interfering with photons. The only thing I'd say that's being interfered is the energy in the laser is interfering with the energy coming back to the same location, and that's why you're getting the rings, is that the emitting light is vibrating the beam splitter, the returning light is getting vibrated by the beam splitter, and that's why you're getting the pattern. Because you're transmitting light through something you're agitating. So if they did do this experiment with single photons, I would predict no patterns. That would be my prediction, yes. So anyway, cursory, like I said, there's still a lot of moving parts here to go analyze and think about, because again, these could just be refraction lines. These could be internal reflections created inside the beam splitter. So the light is reflecting off the two surfaces, and every other reflection is a transmission. And that accounts for the pattern you see, is that when the light's going through, it's transmitting on every other reflection. It's transmitting 50% of the light that hits. So it loses 50% here, it hits, loses 50%, loses 50, well, or 20%, maybe it's only 20%. See, that's the tricky part, is it's hard to tell the intensities. So if it loses 20%, it was a lot of rings, so it's probably only losing 8% or something, maybe, who knows. But I think it's internal reflection, refraction inside the different surfaces of the glass. That's why I want to try it with one piece of glass, just because then you can know it's only two surfaces. and you can sort of account for all the internal reflections a lot easier. So it will be interesting to see if it creates the same pattern with just a plain piece of glass. So that'll be the next experiment I'll do. Alright, so do a commenter, the snarky one. So, it had posted before this, I've pointed out how the double slit and single slit pattern often looks nothing like what it should look like, in that the math basically says it should be a gradient. So it should be very light, and then it gets fades very, I don't know how to do fades with a, and again it gets bright, and then it fades to nothing, and then it gets bright, and it fades to nothing. And so it should have a real flow look to it, real sine wave kind of flow. It shouldn't look at all barry. It should look very flowy, flows into the dark, and then it flows up to a peak, and then it flows into the dark. So it should have that appearance of a very soft gradient of change. And all the ones I've seen, except in electrons, are much sharper. So in the electron experiments, it tends to have this appearance of a gradient. Okay, it has this smoothness to it. And I would argue that's because electrons in this experiment are hitting electrons, which means they don't actually hit each other. They magnetically repel. So when the most contacts will be side to side kind of contacts. The electron won't hit head on. If it hits head on, then this electron stays and this electron will leave straight. But when it's any kind of periphery, you'll get parabolas of different kinds where the path of the electron will be bent. And that's why it's much smoother with electrons. It's because electrons are magnetically repulsive, and they're just pushing each other and creating paths that aren't as angular. I shouldn't say they're not as angular, because they are once they start going straight again. So the only point there's a bend is where the two forces, the force of this electron repels this electron, the force of this one repels this one. Those forces have to combine, and once they combine, then it goes straight. But the point is that that's where there's all these variable movements, where when it's a photon hitting electron, there's no variance in the movement, not nearly as much, and the electron moves a specific distance in its tension with the other electrons, and that specific movement out and then back is what creates the new path of the electron. So it's a much more rigid geometry when a photon hits than when an electron hits an electron. And again, in the radio wave experiment, none of this is happening. There is no interference. There's just the two signals end up jamming each other. So there's no real interference in the sense that there's no radar plus radar equals no radar. Like when there's of these two different distances, this just creates the circumstance where the two signals are out of phase. That means they're on where there is a ton, where there is a ton becomes out of phase, which means there's extra tons. And so say it's a 2.4 gigahertz microwave, it ends up being a 5 gigahertz signal, and unless you're looking for that 5 gigahertz signal, you won't see it, because it can't. The detector is looking for 2.4 gigahertz, and it's not going to see a 5 gigahertz signal. And that's what the new signal is going to be when the two out of phase streams of photons interact with each other. So it's a completely different functional reason why there's a pattern. They have nothing in common. There is no wave property between them that's common. They're creating a pattern for entirely different reasons. In the small micro experiment, It has to do with photons hitting electrons. In the big, large wavelengths experiment, it has nothing to do with anything hitting anything. It just has to do with frequencies being superimposed and therefore jammed. And but physics, they see this pattern and they just say pattern, pattern, interference, interference. It's always interference. Wherever there's an on-off pattern, interference. And it's kind of childish not to think that's how physics works. That every time the simplest pattern in the universe shows up, on, off, on, off, on, off, we should jump to the conclusion that something had to interfere with something else. Wrong conclusion. Alright, that's probably enough. There are some other subjects I could go over. Like the Jeff G guy, it's this really annoying, where they do the energy equals Planck's constant times frequency. This is the Broglie kind of bullshit. And, it's such a misunderstanding of why frequency is meaningful. I've, of course, made the tipping point argument that, electrons are moved because if they rebound. Electrons are in tension. They're always, when there's any amount of electrons around, they will balance their pressure between each other. Just because they have to. It's what magnets do. And they're magnets. They're monopoles. And when they're repulsing against each other, they'll end up balancing either their distance or the amount of force between them will have to balance. So there's the same pressure between each electron. So when you nudge an electron with photons, you push it, it's going to tend to want to stay in this position because it was the quiet space. This is a condition that has tension, and if it tries to move, the others are going to compensate for that movement, and it's going to be essentially pulled back into the fold. And so the idea would be is if you want to try to knock an electron out, you're going to have to hit it first to move it out a little bit, and before it can rebound, you hit it again, and then you'll release it. But if you let it rebound, then you'll just keep bouncing it. You'll never get it out because you never stretch the rubber band, so to speak, far enough to break it. So it's exactly like trying to tip something over that wobbles. If you throw a baseball at something and it's something that can wobble, you want to throw the baseball, the first one, get it leaning, and then hit it a second time while it's leaning and it'll be knocked over. Or you want it to wobble and then go a whole wavelength and then hit it again. But that's an illusion of more energy. It has nothing to do with how much energy the balls had that you hit it with. It just has to do with the subtle fact that everything has a tipping point, and how you apply energy will make something look more energetic. If you apply it badly, you won't get a result. If you apply it precisely, you'll get a result. And so this is another thing where these smart physicists should have been looking out for that. They should have known that there's structure that might make something look like it's more energetic because it creates more of a result. But it creates more of a result just because of timing. The bullets don't have more power. It's the same amount of energy, same amount of baseball, same amount of speed. It's just applied at a timing that is conducive to the result of knocking the pen over. And these are, easily diagrammed errors. And I think I've plainly diagrammed them as really viable explanations for the wrong conclusions made by physics. So again, this idea, this is Planck's constant, so you can take it out of here. They've basically made E equal frequency. And frequency does not mean more energy. And it only means that inside the circumstance where two electrons are pushed together, and you increase the vibrational frequency between them, which increases the pressure. But again, that's just circumstantial. As soon as you move those electrons apart, you lose all of that energy, that extra energy. It's only circumstantially energy. And obviously it takes energy to move them together, which is the key fact, that you haven't created energy by moving them together, because it's going to take as much energy to move them together as you're going to create in terms of the higher frequency in between them. So there's no free energy here, and this whole idea of frequency equaling energy is just notionally wrong. Bits moving the speed of light is energy. The little photons moving is energy. How regular their movement is, or what frequency they're moving at, doesn't make them more energetic. It just means that obviously if you shoot bullets, fast, and you shoot them slow, that in a certain period of time, if that's all you were measuring, more bullets, twice as many, blue light has twice as many bullets as red light per a unit of time if shot consistently without breaking. And so, but that doesn't mean blue light is more energetic. It just means that per unit of time you can push more energy into a system with blue light than you can red light. But the bullets themselves are not more energetic. They're going the same speed, they're the same size. There's no increase in energy innately or inherently. Alright, now I think that's enough of a video. So that's the subject. It's good for conversation too. Anyway, so until the next time and such, so forth and whatnot.